Welcome to this video on inclusion dependencies, the mathematical engine behind query optimization, data integration, and big data profiling in relational databases. At its core, an inclusion dependency is a fundamental rule where every combination of values in one set must exist within another set. It defines how data across different tables relates through set containment. A common example is referential integrity. You cannot assign an employee to a department that does not exist. The assigned department ID must be a subset of the total set of valid department IDs. Formally, an inclusion dependency requires two conditions: arity matching, where the number of attributes on both sides is equal, and domain matching, ensuring data types are perfectly compatible. In 1984, researchers formalized rules of inference including reflexivity, projection, and transitivity. These allow systems to logically deduce new, hidden dependencies without needing to scan the underlying data. When looking at relational design, functional dependencies operate within a single table to ensure value uniqueness, while inclusion dependencies operate across tables to enforce set containment. The implication problem tells us that while we can algorithmically deduce dependencies separately, combining functional and inclusion dependencies becomes undecidable, effectively simulating a Turing machine. In practice, query optimizers use these dependencies for join elimination. If the database knows a relationship is guaranteed, it can bypass an expensive join, significantly speeding up query execution. For data integration, inclusion dependencies act as a mathematical bridge. By discovering containment across distinct systems, engineers can safely join and integrate data from separate, unmapped schemas. These dependencies also help solve schema drift. By scanning raw data to uncover hidden inclusion dependencies, administrators can reverse engineer undocumented databases and re-establish strict referential integrity. Automated discovery of these dependencies is nitrogen monophosphide hard. Algorithms like Spider handle unary dependencies, while more complex multi-column dependencies use probabilistic structures like Bloom filters to work with massive datasets. Ultimately, while functional dependencies ensure a table makes logical sense, inclusion dependencies provide the backbone of connectivity, dictating how data relates across the modern enterprise.